All right, so for this question, we're trying to solve a polynomial inequality. And the first thing that you should notice is that if this was an equal to, if it was x minus 8, x plus 7 equal to 0, we would get super excited because we would say it's parentheses, parentheses, it's already factored. And so because it is already factored, we will set each of those factors equal to 0. Now, the fact that we have a greater than, that is going to change things a little bit, because now instead of just setting it equal to 0, this greater than means that we are going to have to test a point on each of the intervals. So our first step in solving this inequality is going to be the same first step as if it was an equation. We're going to change it to an equal to, and we're going to say, okay, it's already factored, so I can set these factors equal to 0 and get x is equal to 8 and x is equal to negative 7. Now, when we get those two numbers, if it was an equal to, we'd be done. But now, because of this greater than, we're going to have to go to step 2, where we are going to test a point or a number on this number line. So these two numbers, negative 8 or negative 7 and 8, those are what we call the boundary points. And those will be labeled on the number line. And what that does for us is it divides us into 3 separate test intervals. So we have the interval from negative infinity to negative 7, the interval from negative 7 to 8, and then a final interval from 8 to infinity. All right, so we plug in some number in each of those intervals, and it does not matter which number you pick as long as it's inside of the interval. So from negative infinity to negative 7, I might decide I'm going to pick negative 8. Negative 7 to 8, let's say I pick 0. 8 to infinity, let's say I pick 10. Now, we can test this into any format of the polynomial. So in this case, I would test into x minus 8, x plus 7. So I plug in the negative 8. And you can sit there and figure out negative 16 times negative 1, but really you're just after the sign. So here I have a negative times a negative, so that gives us a positive. And then I repeat this process for the other two numbers as well. So I plug in the 0 minus 8, 0 plus 7, negative times positive, so that gives us a negative. Plug in the 10, 10 minus 8, 10 plus 7, that gives us a positive. Now, once you get all these positives and negatives, you then have to make sense of what this means in terms of our problem. So for our particular question, we were trying to solve a polynomial inequality that looked like this whole function f greater than 0. So what we want here is we want the polynomial to be greater than 0. So if you look up here at our test points, what we see is that for this first interval, we have a positive greater than 0. And for the last interval, we have a positive greater than 0. So those numbers, the negative infinity, negative 7, the 8 to infinity, those are going to determine our intervals. So we will have negative infinity to negative 7, union 8 to infinity. Now, the infinities always get parentheses, but the negative 7 and the 8, because this particular question was a greater than, it was strictly greater than, we will put a parenthesis here and a parenthesis here, and those parentheses are because of the fact that it was strictly greater than. So our final answer would look like this. We would have negative infinity to negative 7, union, parentheses, the 8 to infinity. Now, I do want to just say one thing about this. If the question had been f greater than or equal to 0. With an equal to, we use a square bracket. So in that case, then our answer would have looked like negative infinity, negative 7, but now we would put a square bracket because of the equal to, union, square bracket, 8 to infinity. Okay, so again, the numbers will come from the chart, but then you've got to use the type of inequality, whether it's strict or equal to determine what type of parenthesis or square bracket you will put.